Last time we started section 13.2 talking about reflections. We're going to finish up a little bit of reflections today, and then we're going to also talk about something called glide reflections. So we had looked at these slides so far. This is actually the one that we're on. We're going to talk about what happens when we make certain types of reflections or reflections around certain lines. So the first one is a reflection over the x-axis. So when you reflect things over the x-axis, what it does is it actually changes the y value to be the same one but negative. X values stay the same, y value switches. When you reflect over the y-axis, the y values stay the same and the x values switch signs. And then the other two reflections are over diagonal lines, specifically the line y equal x and the line y equal negative x. So when you reflect over the line y equal x, what you do is you switch the x and y values. And you reflect over the line y equal negative x, you switch the x and y values, and you change the signs. Okay, positives become negative, and negatives would become positive. So what we're going to do is we're going to take an actual point, 2, -3, and we're going to reflect it in these different lines. Okay? So, using those facts from the previous slide, or you can actually draw a picture for this and you can see how they would reflect as well. If you reflect over the x-axis, what do you get? 2, 3 is correct. And if you wanted to justify for yourself that that makes sense, a picture is a great way to do that. So let me actually draw a picture in because the grid is actually on my screen already, which is kind of nice. So I have 2, -3. Actually, I just did that wrong. Sorry. 2, -3. So this is my point. So if I reflect it over the x-axis, it would reflect up to here. Okay, so 2, 3, that makes sense. Reflecting over the y-axis means I'm going to reflect over here. So what would I get if I reflect over the y-axis? -2 and -3 is correct. Now, reflecting over the line y equal x is a little bit harder to do visually, but at least we can see what would happen approximately. So here's my line y equal x. Approximately like that. So what we would expect is we would expect the value would come over here somewhere, right? I mean, approximately, if I reflected it over that line or folded that line along each other. So what would happen, or what would be the ordered pair when I switch these? -3 and 2. And that makes sense in terms of my ordered pair, approximately. That's where that pink point approximately landed. It's pretty close. And then if I would do the line y equal x, I won't change my graph too much more because it's beginning to get kind of cluttered, but my line y equal x would look something like this. I'm sorry, y equal negative x would look something like this. So the pink point would get reflected up here, right? Would reflect up for line y equal negative x. So I would switch my x and my y, and I would change my signs, right? So what would the value become? Yeah, 3, -2. And again, the pink point that I just plotted looks like it's indeed at 3, -2. Okay, so it's your choice whether you want to sort of memorize this list of facts, whether you want to draw a graph to visually give some visual perspective to it, or whether you want to write on a note card. Any of those are perfectly fine ways to deal with this particular problem, but they're all equivalent. All right, this is actually a piece of a book. And so like an actual textbook for middle school. And they're asking us to decide whether the images are related by a slide. So a slide, we've got other words for them sometimes too. A slide is what we call a translation. Is that pink showing up okay? Yeah? Okay, so that's translation. That actually is pretty bad. I'm sorry. I won't use pink. That backdrop's not real helpful for that. I'll use this one. Flip. What does flip mean? Somebody said it. What is it, Dylan? It's reflection, exactly. A flip is a reflection. Okay, that's the ones we're actually working on, reflection. And then turn. What is a turn? A turn is a rotation. So we can use their language, we can use our language, but I just want to make sure that everybody understands that they mean the same thing, okay? And there is more than one answer on some of these. So it says to decide if it's a turn or a rotation to describe it. Describing means to talk about clockwise, counterclockwise, and a degree measure. That's what it actually means, okay? So let's take a look, and some of these have more than one answer that could be used. On the first one, what does it look like happened to get from the dark purple image on top to the lighter purple image on bottom? Looks like a reflection. That's probably your easiest way to get there, right? Maybe not the only way, but the easiest way. And if you were to draw that in, that line of reflection, where would it fall? Horizontally between them. Very good. How about the second one? What would the second one look like? Or what do you think the second one looks like? A turn or a rotation? I agree. So this one's a rotation or a turn. How? What is it? I'm sorry, my throat is tickling and it just hasn't stopped tickling just yet. Please continue, Rachel. What did you want to say?
I was just saying it could also be a reflection.
It could also be a reflection. You're right. I'll write that one down in a minute. You're right. Let's finish the part for if it's a turn first. If it's a turn, what is it a turn from? What is it? Clockwise. Okay, so we could turn clockwise. How much?
90 degrees.
Good. Clockwise, 90 degrees. And it would be turning where? I mean, where would the turning point be? Can you tell?
The origin would have to be like, if it's a square out of those two sides that are kind of together, it would be right in the middle of the square.
It'll be right here, actually. Or no, I'm sorry. What did you say?
I said right in the middle of the square.
Yeah, you're right.
Okay.
You guys see that yellow point okay? Yeah, if we sort of, if you imagined putting this thing on a spinner and you were to spin it left, clockwise, it would actually land right here, and that would be exactly where we would want it. So you're right, Alicia. Okay, so this could be a rotation or a turn. But Rachel's right. It also could be a reflection. If it were a reflection, what would it be around? Or a flip? Yeah, it'd be around y equal x, like right here. Can you imagine reflecting it over that line and you'd get the bottom one? Or over the line and get the top one? Yeah, good. So you have two options, reflection or a turn. What do you think happens on 3? That's a translation or slide. I'm going to write slide just because it's shorter. So we've got it slid. It is slided. That's not right. Slid. It's moved. Shifted. What did you call it? Shift as well. It's shifted. What about number 4? What do you think happened on 4? Probably most likely a rotation or a flip or a turn. How much and what would it be?
Is it a half turn?
Yeah, a half turn. A rotation, you can write half turn. You could write that it was 180 degrees. You can see where the center is. Where's the center on this one? Where are we rotating it around? Yeah, this point right here in the middle, right? If I rotate around that, I'll have the same image. Yep. All right, number 5 says, Maria says that the figures at the right are related by a 90-degree turn. Paul says they're related by a 270-degree turn. Who's right? Explain. Both are right. Why are both right? How is that even possible?
Clockwise or counterclockwise?
Yeah, it depends on if you go clockwise or counterclockwise, right? So one is turning counterclockwise. The other counterclockwise. Is there any other possibility of what they could be doing that you see? Another possibility is that one of them might be considering a different point of reference. So like one of them might be saying I'm starting at the red flag, and the other one's saying I'm starting at the yellow flag or orange flag. And then so they could both be going, say, clockwise, but they're going clockwise from a different starting point. For instance, if this is your starting point and you go clockwise 270, that's where you would be. But if this is your point of reference and you're going clockwise 90 and then this is where you would be, you'd both be going clockwise. You'd just be starting at a different flag. So that's another possible perspective difference that they might be talking about. What point are they rotating around on that one? Can you tell? Yep, where the flagpoles meet. Good. All right, we've got just a couple more things in this section. We mentioned mirrors last time, and we're going to talk just a touch more about mirrors today. I don't know if you've ever played with mirrors and light before, but they do some interesting things. Reflecting light off of a mirror is our next slide. If we were to shine a flashlight on the mirror like the image shows on our screen, the angle of incident is the angle formed by the incoming ray of light and a light perpendicular to the mirror, and you can see it marked on that diagram. And the angle of reflection is the angle between the reflected light that comes off and that line perpendicular. And we've talked at different points in this class about how we get congruent angles. And this is one of those places where we actually have congruent angles formed when we bounce light off of a mirror. So the angle of incident and the angle of reflection are actually congruent. We have one more type of reflection in this section, and it's called a glide reflection. A glide reflection is actually a combination transformation. It consists of a translation, or a slide, followed by a reflection, but it's a very specific type of reflection. It's in a reflection in a line parallel to the slide arrow. A glide reflection is another isometry. So the example here shows the full range of motion of what a glide reflection does. So the silhouetted footprint is your original image, okay, so that's the pre-image, and it slides to where the blue foot is, and then it reflects over that blue line to where the cream colored foot is on the bottom. All right? So the pre-image is the hollowed out foot. The image is actually the cream foot on bottom. That's a glide reflection. It's a slide and a reflect. And no glide reflection discussion would be appropriate without reading footprints. So we're going to read footprints to end our class today. If you haven't heard this before, then I'm glad that I get to be the one to share it with you. One night, a man had a dream. He dreamed he was walking along the beach with the Lord. Across the sky flashed scenes from his life. For each scene, he noticed two sets of footprints in the sand, one belonging to him and the other to the Lord. When the last scene of his life flashed before him, he looked back at the footprints in the sand. He noticed that many times along the path of his life, there was only one set of footprints. He also noticed that it happened to be at the very lowest and saddest moments of his life. This really bothered him, and so he questioned the Lord about it. Lord, you said that once I decided to follow you, you'd walk with me all the way. But I've noticed that during the most troublesome times of my life, there's only one set of footprints. I don't understand why, when I needed you most, you would leave me. The Lord replied, my precious child, I love you and I would never leave you. During your times of trial and suffering, when you see only one set of footprints, it was then that I carried you.